Now the next module would be about installation. So let me share my desktop. Okay, so in the earlier modules, we reviewed the system architecture first, the deployment architecture, and now we are basically building up all together with the installation. Okay, for installation, this is the learning objectives. I'm not putting it in presentation mode because I will need to switch to another document in the next slide. So our learning objectives are how to find the support documentation, which is actually the main thing. Be able to describe the high-level steps required to install a SM.I.LE80 system, how to select an installation scenario and check the system requirements, understand the importance and usage of property JSON file, and then use the main installation script using the dash build and dash deploy switches, identify and disable optional component, if any, and finally the startup of the system and the first web UI access. Okay, so let's start with the documentation. We have two reference documents. One is the system configuration. The other one is the installation guide. We keep a copy of each of these documents for every SM.I.LE80 version. So we have the SM.I.LE80 1.1.1 that is being released in these days. And we have both the system configuration and the installation guide for this release. The system configuration is targeted mainly for BAs because it contains the configuration of the system, the sizing requirements in terms of RAM, CPU, and so on. So it's something that BAs use for the proposals to the customers to propose, let's say, new installations. While the installation guide is document mainly used by the project team when they start development and when they install SM.I.LE in field. So this is your document. Now I will show you briefly how the document is structured. Okay, so this is the document. So you have one introduction part that basically recaps what you have already learned in the former modules, so which are the components, load balancer, web server, BFF, and so on. It explains the basic configuration, that is this one, and the HA configuration. And for each configuration, you have where each application and services are installed as primary and backup server. Then you have a paragraph with installation requirements where you can find all the requirements for the different installation scenarios. Okay, now I'm going very quickly because we will then talk about each of these sections. You have the list of all the required third-party software, the supported browsers, and some installation notes. And finally, let's say that we start with the installation procedure. So you have one chapter for the high availability if you're installing this scenario. Okay, I will fly over to 4, which is the same. So you have all the installation procedure for the HA. Then you have all the installation procedure for the basic configuration. So same procedure for the basic configuration. And you have to choose either one or the other, of course. And finally, at the bottom, there is another chapter that is 5. So once you are done with all the installation, you have the getting started. So how to find the programming guide, that is your starting point for your customizations. And you will also find the troubleshooting guide, architecture, a lot of valuable resources here in this document. How to access the web UI for the first time, so username and password to be used. How to remove pages and items if they are not needed. Now we'll go also about, we'll talk about this as well. How to launch the layout configurator tool. That is a tool that will take from the layout DB3 information about locations and stations and will put them inside the SM.I.LE80 database. This tool will be covered by another learning session. And finally, some hints about the database maintenance setup. Okay, so this is the general structure of the installation document. Okay, now let's go to the presentation. Okay, so we are following the installation guide. I'm not exactly rewriting the installation guide in slides because it would make no sense, but I would like to give you a general understanding of the installation procedure and which are the important points, the points to look at. So first, you need to think about the deployment architecture that you just reviewed in the former module. So SMILE is a pretty complex system. There are different machines, there are different operating systems because we have Windows and Linux. We have different services, a lot of databases, a lot of configuration items. So the goal of the SM.I.LE80 installer is to make things as simple as possible. Okay, so to try to hide the complexity of the system to the person who installs it. We are on the journey to make things simple. Something is, I think, pretty good. Some aspects still need to be improved, but anyway, our effort is to make installation as simple as possible. Okay, so here on the bottom you can see the different steps we have to take to get from the beginning with empty servers till an installed system. Okay, so we will have to do all this stuff in the middle. Okay, so the first thing, we have to spend some time before even starting to build the image. So the first thing to do is to choose an option, an installation option or installation scenario. Okay, we have three different options in 1.1 that were explained in the deployment session by Giuseppe. So we have installation from scratch from a fresh installation with HA, with high availability, with 9 machines. We have an installation from scratch in basic configuration with 4 machines, which is not suitable for production. And we have another installation with basic configuration for production. The difference between these two configurations is the sizing of the virtual machines, because if you build a system where you're going to develop, so for your testing and development, you can follow the basic configuration for the test environment. But if you install a customer setup, you need to follow one of the two production environments. Okay, so selecting an installation option is the first step. Remember that it is not possible to upgrade an existing SM.I.LE 1.0 to 1.1.1. This is not possible. So all the installation options for 1.1.1 is starting from an empty system. Okay, the second step, of course, is once that you chose what you want to accomplish, what you want to install, you have to review the system requirements. The system requirements have already been covered in the deployment architecture by Giuseppe, so I'm not going to restate them. For each scenario, you have a number of virtual machines. You have some requests about resources, CPU, RAM, and disk, which are detailed in installation guide. And you have an installation procedure. So depending on what path you choose, you have a different installation procedure. The installation requirements are reported in chapter 2 of the installation guide. Okay, a few things to be aware. Okay, first, when you're going to compile the code, which we will see in the build image step, you have a server which is the engineering station, which can be your laptop, and this engineering station must be connected to internet because it needs some access, some libraries from the internet. So you need to be connected. You cannot do it in a plant where you have no internet connection. Okay. However, if you go in production on a customer plant, on a customer's warehouse, during installation, with exception of Red Hat Linux, you don't need the internet connection. So we support the offline installation. So in other words, the SM.I.LE80 image is able to be installed without internet connection once that you have compiled it. During installation, you need to disable all the firewalls. They can be re-enabled during after installation when you operate the system, but during installation you need to disable them. Everything is written also in the installation guide, by the way. The SM.I.LE80 and third-party software must be installed using the same OS user. So do not switch users when you install third-party, and when you install SM.I.LE80, you need to use the same OS user. This OS user must have full access to the system, because installation scripts will take control of your system, will configure cluster, will discover the network, need to do everything. So you need a powerful user to install SM.I.LE80. Then it may happen that PowerShell does not allow unsigned PowerShell scripts to be executed. In this case, you will need to execute this command to enable, let's say, to bypass this policy. Okay. Also, this is written in the installation guide, of course. And finally, the image zip needs to be unzipped in C SM.I.LE80 or anyway a short path, because otherwise there is a path to long error while unzipping. When you get the path to long error during the unzip, the unzipped folder is unusable. It needs to be deleted and re-unzipped, because some files are actually opened and some are not. So all these notes anyway are also present in the installation guide. Pay attention to them to avoid problems. Okay, engineering station is the term we use in the installation guide to indicate the server where you are building the image. Why do you need to build the image? SM.I.LE80 is, as you know, partly delivered as open code and partly delivered as closed executables. So the executables are already compiled and present in the image, but the image as it is cannot be installed directly. So in other words, you cannot deploy directly what we deliver to you. The first step, okay, all the default, all the say default implementation are present, so you can just build the image as it is, or you can customize the modules you need to customize, like LGV Manager or HDSM and so on. But anyway, you need to take a build step to obtain something that you can install. So at least you need to build. The server on which we compile the code is the engineering station. So the engineering station has some prerequisites that are the Visual Studio Build Tools and the .NET Developer Pack, which are also listed in the installation guide. Another software you need to install is RabbitMQ. As we saw before, this is required if you are in HA installation on all the core servers, or with the basic configuration on core server 1. So you need to install Erlang OTP and RabbitMQ. Instructions are also available on the installation guide. You will need the SQL Server and the failover cluster manager installed on the core servers as well. And also the procedure is detailed in installation guide. There are a couple of things to be done during the configuration of the SQL Server. You need to enable TCP/IP protocol for remote connections and set the collection property to rating 1 general. Also, the steps to do this are say reported in the installation guide. Okay, smart. Smart is also a prerequisite. So all the software we are reviewing now needs to be installed manually. It's not part of the SM.I.LE80 image. Smart is not inside the SM.I.LE80 image. It needs to be downloaded and installed separately. In the installation guide, we do not provide the installation instructions for Smart because there is already installation guide for Smart, so we don't want to conflict with those steps. But we provide some, let's say, a checklist of things to check to do to make sure that Smart is correctly integrated in SM.I.LE80. Smart has to be installed as a Windows server with the Smart Service Installer executable. Very simple step anyway. And in addition to this, in HA configuration, the service execution mode in Windows must be set to manual because Smart will be managed in the role by the failover cluster manager, not as a standalone service. And in high availability, in high availability, you need also to install the high availability executable for Smart, which is a tool that synchronizes the Smart files between the working image and the standby image. Okay, so in the installation guide, you will find a set of steps to properly configure Smart to be integrated and work with SM.I.LE80. Okay, then we have a planning phase, very important thing. So what you need to do is to have a clear plan of your system. So in case of basic configuration, you need to assign an IP address to each server, to the web server, to the BFF, to core server 1 and core server 2, and prepare a sort of Excel or spreadsheet with these IP addresses because you will need them during installation configuration. But for the basic configuration, it's very simple because you just need to write down 4 IP addresses. For the HA configuration, it's a bit more tricky because you have 9 different machines, each machine with its own IP address. And in addition, you have to assign one IP address to each role. So one IP address to the role of the Smart service, Smart events, layout, and so on. One to each database availability group, one to each application, so one to SDN, one to LGV manager, and so on, as also explained by Giuseppe in the earlier session. So in this case, it's very easy to get confused with so many IP addresses, so I recommend you to write them down to plan in advance which IP address will be mapped on which machine and which role. Okay. Okay, now we will see what you find inside the SM.I.LE80 installation image. Okay, the image is actually composed of 2 zip files. One is with documentation, and you find only the programming guide and all the supporting documentation, troubleshooting guide, and so on, videos. And the other one, which is the main image, is the one contains the sources and executables. Inside this single zip file, you will find 3 folders, the packages, resources, and sources, and few files. Okay, so install SM.I.LE80 PS1 is a PowerShell script and is the main installation script. It does basically everything. So this is the main point to remember. You have a single installation script. You have a file that is properties.json, which is a centralized configuration point. So this is a text file that you can open with a text editor like Notepad, and you can provide here all the configuration of your system. Then you have the packages folder that contains the executables, the sources folder that contains the source files, and the resources folder that contains additional resources and the scripts. Okay, let's talk about the properties.json because it is connected to the IP address planning that we were discussing before. So the properties.json is a centralized point of configuration for all the properties of your system. It defines the items that are pushed to configuration files in individual applications like LGV Manager, HDSM, and so on. The configuration that is pushed to BFF, the configuration files in load balancer and web server, the role settings in HA configuration, and the database access credential and RabbitMQ access credential. So this is the place where you define all your system. And you have to remember two things about the properties.json. First, it is critical that the values that you set in these files are correct, because if they are not correct, you are configuring the system in a wrong way. And then after deployment, it will be very difficult and error prone to find all the errors and fix them. So be very sure that every property in the property.json file is correct. The second thing to remember is that properties.json is a JSON file, so it has a format. So make sure that you don't alter the format, because otherwise the installation script will not be able to read it properly, and you will get some errors. So it's better to make a copy, maybe a backup copy before editing it, and then be very cautious about the format. That means the commas, the quotes, the brackets, and so on. Okay, now rather than following the slide, I will show you how the properties.json is formatted and what information it contains. So this is a real properties.json taken from 1.1.1. First, you have the app destination directory, which is this value, C program file C80 group. This is the place where all your application will be installed. So you have the option to configure this folder. Remember to put the double backslashes because it's required by the file. All these items are described anyway in the installation guide, of course. So I'm just making sure that you pay attention to this file. If you want, or the customer wants to install in a different volume or in a different folder, for any reason, you can modify this, and all your application, BFF, LGV Manager, HDSM, will be installed in this app destination directory. Okay, here you have to provide the name of the layout directory that is used in Smart. And then you have the three classic networking values that are the network, the subnet mask, and the gateway. Okay, then we have the section called addresses. Okay, here you have to provide each property is described inside the installation guide. You have to provide the IP address of each role inside the failover cluster manager, and of the load balancer, web server, BFF servers as a machine. Okay, each of these properties is, of course, described correctly, completely in the installation guide. So this is why it's very important to plan in advance and write down all the IP addresses, because you have to provide each of them here. Okay, then in the section below, you have the database settings. So in the database setting, you can provide the name of the database. This is configurable. It means that by default, the LGV Manager database will be named LGV Manager, but you can modify it. Same for SDM, for DB history, and so on. So you can choose the name you want for each database, and you can choose which is the database name user and the database password. And finally, at the bottom, you have here the RabbitMQ credentials that are the ones that I mentioned during the initial session, the system architecture. So it's very important that you remember them, because they are the console access, the RabbitMQ console access credentials. And here you have to provide the credentials for SSH access to the load balancer and web server machines. Okay. My suggestion is to keep the properties.json file somewhere, because it contains okay, it's something very, very, It's something that you have anyway to hide because it contains in clear text all the credentials for DB access and RabbitMQ access. So you have any way to store it in a safe place where it's not accessible by someone that is interested in breaking the system. So because everything is in clear text, it's unprotected, but it's very useful to you to remember the access if you forget them, because once that you deploy on the system, all these credentials will be encrypted. So on configuration files, you will not be able to see them. You will not be able to read them in any place. It's the only place where you write them in clear text. Okay, so properties.json. So we reviewed how you can specify the destination directory, the network settings, and all the IP addresses of each component of the system. And the database properties, so the name and credentials, and RabbitMQ credentials. Okay, at this point, if you set correctly the properties.json file, installation is actually very smooth because the steps are building the image. So you have to call on the engineering station, so potentially on your laptop, the install SMILE80 PS1 script, providing the dash build script, and you build whatever is customizable. So you build the LGD manager, you build SDM, you build BFF, and you build HDSM if Stacker Crane or Smart Store is present. Otherwise, you can even skip this step. So basically, you build all the open components. Remember that you have a default implementation for each of them, so you could build them even if you don't customize them. Okay, after your customization, of course, you have to rebuild to include your customizations. Then there is a step, an intermediate step, that is the creation of HTTPS certificates that are required on the engineering station, and also you have to repeat the step on all the core servers. So this step will create all the self-signed certificates, but in the security session, we will cover more of this topic. So just to tell you that we have the capability with the installed SMILE80 script to generate self-signed certificates, which are by default lasting for 30 years, and you can change this setting, modifying the number of years of the duration of the certificates. For the load balancers, anyway, we recommend to use official certificates released by a certificate authority. All the other ones are self-assigned. There is another step that is to secure communication with RabbitMQ and with the SQL Server. Also, these connections are encrypted with using these commands: active encryption database and configure RabbitMQ. And then we are ready to start the actual installation. So we have built the image, we have created the certificates, we are able to go on core server 1 and deploy the databases. This single command will create all the databases on core server 1. If you are in basic configuration, you just need to do it once. If you are in HA configuration, the command is the same, but you just need to add the dash cluster switch because the databases will be created and will be also replicated on core server 2, which is the database backup server, the backup server, sorry. So the step is very similar. You just need to add the dash cluster option at the end. All the roles for the availability groups will be automatically configured by this installation script. So you don't need to bother about them. Okay, the next step after installing the database is to deploy the services. So to deploy the services, we will use the dash deploy switch. Again, a lot of manual work in the configuration of the application, for example, configuration of SDM, reporting, and so on, is avoided because we use the values that you provide in the properties.json. So each configuration, each application will be configured automatically using these values rather than the person who installs having to bother about individual configuration files. Comments for the basic configuration in the HA are very similar. For the basic configuration, you just need to do these steps on core server 1 without the dash cluster switch. So you run just deploy SDN dash application, deploy reporting, deploy automatic reporting, and report configuration, which is the reporting configuration tool. For the HA, you have the same steps, but on core servers 1 and 2, which is the backup. And you have to add the dash cluster option. So very, very straightforward installation procedure. For the backend applications, so LGV Manager, Smart Events, Layout, HDSM, and Ubiquity, the command is the same, but in this case, you have to execute them on core server 3, where they are installed, and core server 2, which is the backup. These steps, of course, are okay for server 2 only for HA. Otherwise, you have okay, server 3 will be named server 2, but anyway, you have to execute on the other server. And in HA, you have to provide the dash cluster option, while in the basic configuration, you don't. It's always better anyway, even if you don't have to edit the files, to check the correctness of the configuration, which can be found under program files, E80 group, and the name of the service or application. And you find the config file and validate the values inside the configuration file. Just a check because you don't need to update it. Deploy BFF is a single line command, so it just installs SMI.LE80 deploy BFF. It has to be executed on the BFF server or BFF servers if we are in HA scenario. And again, it's better to check the configuration file even if you don't need to edit it typically. And finally, so the system is basically installed if you have optional modules that are not installed, like HDSM, MMS, or the Ubiquity devices support. In this case, you have to perform some manual steps to remove completely these modules. Okay, the steps are the following. Inside the reporting service and automatic reporting service, you have to remove the connection strings toward these databases, especially the first two, from the configuration file. Inside the installation guide, you find the detailed steps. It's just to give you an overview of the procedure. So remove the connection strings from the reporting services. You have to disable some reports, the reporting MMS and reporting machines, and then to disable the Smart Store and Crane Manager. So these these three commands, of course, need to be executed from the SQL Server management system. And inside BFF, you have to navigate in C, netpub, www-root, SMI.LE80 share settings, general settings file, and set the HDSM and MMS to false. Otherwise, you will get an error on the diagnostic check because these components are monitored. Finally, there is also in the installation guide a procedure to remove the configured configurable pages that are not required, like all HDSM pages and all MMS pages. So bottom line, remember that if you have a warehouse where HDSM, for example, is not needed, you will have some additional steps to remove it, even if you don't install it. Okay. Okay, the next step that is about the front end is the installation of Docker. Installation of Docker is a bit different between the Ubuntu and the Red Hat operating systems, and requires some steps on the Linux interface, so on the shell. Okay, I didn't report it on the slide because it's all inside the installation guide. You just have to type the same commands. So the thing to do is to state which is the operating system on which let's say the Linux part will be running. So you can have either Ubuntu or Red Hat, and you have a procedure which is a bit simpler if you have internet access. So if you have internet access and are on Ubuntu, you have to execute exactly the commands reported here. You can copy paste on the Linux shell. If you have Ubuntu, but you don't have internet access, you can follow the offline mode instructions here. So in this case, you will have a tar.gz file inside the SM.I.LE80 image to unzip and then execute some commands. While if you have that Enterprise Linux, we require, in any case, the internet access. There is no offline procedure, and you have to follow the instructions reported in this section. Okay. Again, you just need to get the commands and copy paste on the shell, exactly as they are written. Okay, once you have Docker installed, that is the base to install all the containers, you can install the front end. So the front end is again inside the installation image of SM.I.LE80. So you just have to run the installation script, dash deploy, and let's say the thing the component you're installing. These commands are executed on the PowerShell interface of the BFF server. So you need to go on the BFF server and execute on the PowerShell inside the unzipped image, deploy dashboard web, deploy Minio, and deploy load balancer. Again, all the parameters required to configure these three components are inside the properties.json file. You don't need to provide any IP address, anything as argument, because everything will be taken from the file. Okay, so the interesting thing is that when installing the web UI and Minio and load balancer, you actually execute commands on the Windows PowerShell. You don't need to execute anything on the Linux shell for this part. Okay, all the applications are started when you install them, with the exception of Smart, that you need to start as a Windows service or role if you are an HA. LGV Manager and HDSM also need to be started as Windows services or roles, same as all the backend services. BFF is started automatically. You might need to restart it using IIS, for example, if you configure the locations. In this case, BFF needs to be restarted at least in the layout API and the handling unit, handling systems API. But anyway, you already know how to start or restart BFF using the Internet Information Services. And the front end also is automatically started after deploy. Okay, it's the startup sequence is not, let's say, there is no predefined startup order. Usually, it's good to start from the bottom to the top, so starting from Smart and going up, backend, BFF, and front end. But just because you can make some checks, so if you want to see if LGV Manager and Smart get connected or BFF connects correctly with the backend and so on, this sequence provides you a bit more confidence regarding each module working correctly. Otherwise, it's more difficult, but it's up to you. There is no predefined sequence. Okay, finally, at this step, you should have all the components installed and running. So the first web UI access through the browser can be done using E80 administrator, and the password is exactly typed like this. I can share it on the installation guide and on the slides because you must reset it on the first access, and you have no option to get this default password, so you must reset it. So I recommend to note it down somewhere because it will be the only way to access the system always. So it will be a sort of let's say general password. If every other access is lost, this one will be the way to access your system. So first access E80 administrator, which is a default user created by the installation, and password, and then you have to change the password at first access. Okay, how to use the system once that you have installed it. We support 3 different browsers that are Chrome, Edge, and Firefox. We support the latest version of each browser when we deliver the SM.I.LE80 image. Okay, so we test until the last available version of each of these browsers and support these 3. We don't support other browser types. And moving forward, so installation is done, it will be a matter of configuring the system, which will be the subject of other training modules. So what can we take out from this module? First, the SM.I.LE80 image comes with 2 zip files, one with the image and the other for documentation. We have seen that we have a main installation script that is the install SM.I.LE80 PS1, that is a PowerShell script. And this script takes care of building, deploying, setting up the certificates. So basically it does everything. You just have one script and one configuration file that is the properties.json file. The installation phases are identifying a scenario, so what you want to install, and check the system requirements. Then you have to install the third-party software. Then probably we have to plan the IP addresses and note them down to set them in the properties.json file. You build and you deploy. Okay, so it's these are the phases for a successful installation of SM.I.LE80. Okay, for any more detail, I recommend you to, of course, to refer to the installation guide that is updated with all the information you need to bring up a SM.I.LE80 system. Okay, so this closes this training module that is the SM.I.LE80 installation. Okay, so now I think we can have a Q&A session regarding installation. If there is anything unclear, anything that needs more explanation before moving to the next topic. I hope that after talking about the SM.I.LE80 architecture and the deployment architecture, it makes sense to you because installation builds on top of these 2 sessions, of course. So any question regarding installation?
I have 2 questions, if possible.
Yes, sure.
In the property JSON, the first one is that in the property JSON, we have a username and password. I think that is because we have only SQL server authentication for databases.
Yes.
There is no supported Windows authentication.
This, I think maybe Giuseppe, can you take this question? Ensure that SQL authentication is the one that we use usually. I don't know if we support also the other one.
So during yes, during the installation, the of course the using of external user, specific user is better. instead the Windows authentication.
Okay. Mm.
So do you see some problem?
No, I didn't understood that. Oh, sorry. During installation?
So during installation, it's suggested to use a not authentication. Sorry, not a Windows authentication, but the a user, a SQL user like SA or SM.ILE80 service.
No, because it's just in some for some customer we have only Windows authentication. I don't know, like Nestle or something like that. So it's just for in custom deploying.
Okay, so this is a good point. We can try to understand this this possibility. So actually, we don't consider the possibility to have automatically in the automatic installation the configuration of Windows authentication. It's possible to modify the configuration files because the installation edit all configuration files that are present in the system. Then it's possible to configure after installation the configuration files to have the Windows authentication, but actually it's not managed automatically by the installation.
Okay.
So we can consider this point for future improvement.
Okay.
But also the deployment of the database will not work if there are no SQL user available, like in Nestle plant.
Okay. Yeah.
The second question was likely because you say that some components like SDM are mandatory.
Yes.
But for freeway projects, so it's just possible only also to have only LGV manager. I don't know. I don't know if for the future projects we will always use SM.I.LE80 just for we will not have any more freeway projects.
I don't know, but what I can tell you is that SM.I.LE80 has as optional component only the HDSM, MMS, and Ubiquiti devices. These are the only components that you can avoid to install. The other are all mandatory, so you cannot install, for example, without LGV Manager or without SDM.
Okay.
Because this system will not work, so they are all mandatory.
Okay, fine.
I have a question.
Yes.
Christian. So when there is the failover cluster in the system, so the installation, what we have to do after installation? So the installation is completed, or we have to use another user guide, like the document that I used in Barilla, for example. So the document is wrote by Mirzet about the failover cluster. So the installation right now is completed, or we have to do some step for complete the configuration?
Thanks for this question, because I think it's an important point. Probably I missed it. So regarding the failover clustering configuration, the guide is actually the one maintained by Mirzet. In fact, you see here, setting up a failover cluster, there is a link to Mirzet documentation. There are some steps that are automated, like always on is automatically enabled by SM.I.LE80 scripts, and anyway, a lot of configuration on the roll is done by the SM.I.LE80 installer. But when it comes to installing the failover cluster and configure that part, the guide to follow is the one from Mirzet.
Okay, thank you.
You're welcome.
And I got a couple of questions, me too. How we decide to use Ubuntu or Red Hat? What's the logic to use one or the other one?
That was a customer requirement. There is a customer that wanted specifically that. I don't know about Ubuntu because it was there since the beginning, so I don't know if Giuseppe knows what
Yeah.
is.
Yeah, it's the Red Hat, it's requires a license. It's managed by customer, so it's typical a request by customer the use of Red Hat instead of Ubuntu. But Ubuntu actually is our first choice to use. So it's the base choice, but there are some customer that want to use Red Hat instead.
Okay. And about the installation script, there is, normally it happened that we need during the development, testing, and also the commissioning on site. Sometimes it happened that we need to change some configuration on some component, or something change due to some problem or some new requirement, like new request. There is a way to update them using the install script, like a footer execute of the script just to update them and keep them aligned, or it's something that must be done manually, let's say component per component and machine per machine.
Yeah, I'm afraid we don't have that kind of support at the moment because the installation script configures everything, but only at deploy time. So when you install the first time. So if you change, you need to change the configuration later. You don't have a tool or utility to reconfigure the system or reconfigure part of the system. So you will have to do it manually. But anyway, if there are some cases that are typical and you hit them frequently, we could work on it. I mean, it's something that we could take as a request from your team. So
Okay.
at the moment, we don't have the support, but if you can suggest some case, not now, but in general, if you can suggest some use cases, I think we could work on them and make it more powerful.
Okay. Thanks. Yeah, one last thing
Sure.
about DNS. There is something that we need to ask, like the customer, what he need, or the IT department of the customer need to provide us. So just those two load balancer.
Yes, so for DNS is actually, let's say, strictly required only in high availability. So if you are in the basic configuration, you have one single load balancer and you can use the IP instead of the name. For HA, it is required and you need these two entries.
Okay, so those are okay. Good, thanks.
You're welcome. Any other question? Okay. Okay, I think then we can switch to the last presentation. So Giuseppe, if you want to take over.
Yes.
Thank you.
I want to share my screen. Just a second. Okay. So do you see? Okay, so about the last module of this first day of training, we speak about security, and in the specific three aspects of security: authentication, that's how the system manage the authentication of users; authorization, with aspect of users roles and permission and claims, and encryption. It's related to connection, how the managing of the certificate and the encryption of data in the system. So let's speak about authentication, and we can consider our system as a centralized authentication web-based, and there are a single server for authentication. The specific consider that there are two authentication server in HA configuration, but if you consider a simple configuration, we have a centralized only one authentication service. So this means that all requests are passed through the authentication service, and the user, when try to access to a protected resource on web application, the application requests the authentication to the central authentication server. If in this case, if the server verify that the user credentials are valid, and the access to the resource is granted. So this type of solution increase the security and simplified also the user management in the system. You can see this type of schema, where you can file the load balancer, as we said before, to consider the request from the web application, and the request pass through authentication server that check the credential of the user, and with the use of security database, and then return to the user a token, and that we use for next request. So the authentication server is based on the Identity Server 4. That's its popular open source framework that allows developers to implement identity and access management solution for web application. It's built on top on our application.NET Core, and provide a range of features. But this is a very common framework used in the web application. It's an open source, and with license Apache, and it's possible to use for building commercial product, and it's possible also to customize it, and use the most common protocol OAuth 2.0 for the managing of tokens that we can see also, that we'll see also in this lesson, in this module. So how it works? So the user requests access for a resource, and to a protected resource, such as a web application, for example, or web API. In this specific, the Nginx redirect the request to authentication server with the credential of the user, and then when if the credentials are validated, a token is sent to the application, to the web application, that will use for the next request. And every request sent to the system by the application is validated with the use of the server of the authentication server. Is the token granted by the application is valid or not? This is in general the workflow of the system that we have. So which are the types of the authentication that we have in the system? We have two types of authentication: internal, where the login and password are stored in the database, in our database of security. In the specific, the password are encrypted in the system, are stored encrypted with algorithm SHA-512. So we have another type of authentication that with the use of LDAP authentication and with and specific with Active Directory. The important things in this case is that the user must be fixed in the system, so must be registered in the system and must be present in the database of the system. But the use of LDAP is done for the validate of password. So actually, we don't manage the group of LDAP, and all part are related to the role, and we will see also next. Role are internal of the system. Another thing that we can say that we don't manage a single sign-on, but it's necessary to give necessary login and password to the system for validating. Okay, so let's speak about authorization. We can consider four entities in our system: the user, and that can associate one or more roles, and we have one default user, E80 administrator, with a role of administrator. We have a permission. We have a role. Sorry, we have a role that we consider a group of permission, and we have a permission, a group of actions, and a specific the claim. The claim is a permission granted to a specific user and to a specific role and user for an action. An action we can consider as a single API that is possible to call. So let's speak about claim, and we say claim is a privilege and grant that it's possible to give a user to perform an action, a specific API. This is a screen of a database, a security database, and the specific the claim table. And you can see in particular the fact that the claim is a API calling. So it's the name of API, the path, the area, and the specific the controller, and this is the path and the description. Important things that is the mechanism of automatic register authorization discovery. So the claim in the system are automatically registered, and the system of identity and access management is designed to have the ability to automatically grant access to resources based on a specific policy or rule that we can see next. In the specific, so the claim are automatically registered in the system and added also to the permissions, the permission entities. So in fact, in our system, we have 3 levels of permission. In the specific, we have the view, the level view, typically related to the API get, because it's possible to group in the view permission, and we have the management group, typically related to action that it's possible to perform on resource, and another level that we consider advanced management, that are also action that is possible to perform on some resource, but that we want to protect before the management action, that it's for example some action that we want give possibility only for administrator or user to or role to perform this action. Another type of permission is the configuration permission used for the configuration of our system. And which are the permission in this case? For example, the permission to editing the dictionary, in this case the translation, the pages, for example, the menu, the permission, the part related to the role, user, and permission, and application settings and system settings. So we have these 4 types of permission: the view permission, management, advanced management. As part of these permission, there are also the configuration permission. And there is this is a schema of a mapping of permission and users. So we have a default user, E80 administrator, that you can find in the system when you install the system at first time, and this is an administrator role. An administrator role with all permission associated. So this role is readable. It's not possible to edit it. It's not possible and it's not possible to delete it. There is also an administrator role with all permission, a supervisor role that contains associated the advanced manager permission, and view permission, and also some configuration permission like role management and user management. So we have the operator role with management permission and view permission, and viewer with view permission. So this is a default schema that you can find in the system when you install it, but apart E80 administrator, other roles, it's possible to edit and modify also the permission associated. So about user, as we said, we have a default user in the system, that E80 administrator, and any user can have one or more roles, but only one role it's possible to have active at time. So this is for example a part of the web UI where you can find the role active in this time for this user, for the user E80 administrator. So for the user we can have different roles, but only one role is possible to have active at time. Another things that administrator need to change password at the first login. So for example, for E80 administrator, it's necessary to change password when after installation. Okay, previously we spoke about the possibility, the ability of the system to register automatically the claims and permission to into the system. So this is possible using the specific decorator that you can find in the code of BFF. BFF project or BFF system, that the name is default permission. It's an attribute that it's possible to decorate the method internal, the method of a controller, a specific controller of API. So there are 3 types of parameter that it's possible to add in the decorator. So the advanced controller name management, and controller name view. So this is possible. And each parameter that it's possible to add to the decorator should be a role type that we saw before. For example, administrator, supervisor, operator, and viewer. So this is an example that you can find in the code of BFF project. So we have default permission. So this part it's related to a administrator, advanced management permission. So this part. So in this type, we cannot create a permission, advanced controller name management permission for this controller. And we have this part is related to management permission. So in this case, we want to create a permission for the management and associated to the administrator role, and this is part of the role type supervisor and the role type operator. Okay. Previously, we spoke about the workflow of the access token that you can that there is in the system related to the authentication service. But how the token is associated to the is related to authentication, but how it is also associated to the authorization. How is possible to give the system gives the correct authorization to the system? So it's done with the use of claims that it's not the same claims that we have that you can find in the web UI, but the use is similar. So it's possible the OAuth 2.0 protocol give possibility to associate to the token one or more claims. In the specific, the claims associated to the token are the claims effectively that are in the system associated to the role related to the users. So we have the users that have different roles, and different roles are different permissions. The permissions have different claims associated. So in the token, there are all claims associated to all permission associated to all roles associated to the user. One important thing to say that the token that the system return back to the web UI, to the web, to the client, is not the effectively token that is stored in the system, but a reference token. A reference token is a shorter token that is refer to the correct, to the proper token. I don't know if it's clear. And about the reference token, the duration 8 hours, but there are refresh token with a duration of 20 minutes that the web UI requests periodically. So if there are not web UI that there is not web UI that requests automatically the system to authentication server the refresher token, the token expires. So I want to share you a little demo about the pages of the web UI related to the user role and claim and permission. So if you open the menu of the web UI, you can find the settings part, and you can find the configuration part. And in the configuration, there are 3 sections related to the user, permission, and role. So about role, you can find the E80 administrator about user. You can find the E80 administrator user, for example, and these are and only readable user. It's not possible to edit it. And in the section role, you can find the default role, viewer and operator, supervisor, administrator and the E80 administrator. For example, this is not possible to edit this type of role because they are readable, only readable. But for example, administrator, I can edit it in the for also for administrator, and okay, for default role I cannot edit it. Okay, sorry. Okay, another section is the permission. And you can find the default permission in the system, as we said before, view, management, and I want to show you the advanced management. Okay, this one for advanced management, for example, and you can see this is the claim associated to this part, this permission, for example. Okay, in this page is possible also to create a new permission and then associate the permission, so the claim to the permission, and then associate the permission to role to a specific role. Okay, so let's talk about encryption. And in the system, we have the specific only information that are encrypted in the system are password, and also password in the configuration file, like LGV manager and SDM and BFF configuration files. You can find all password encrypted. In the specific with the CBC cipher algorithm for LGV manager and SDM and AES 256 algorithm for BFF. In the database, as we already said, the password is never in clear text, but also encrypted with algorithm SHA-512. About the connection, this is a picture similar to the previous picture that you have seen, and this is the part related to the connection that are encrypted in the system. Actually, we have the encryption at different level. We use a certificate at different level. For example, from web browser to load balancer, from load balancer to other service like out service, API gateway, and other BFF and database. So we have we configure a secure connection at all different level, also to database, also for services. And actually, we use a self-signed, is a custom certificate for especially for the communication internal in the system but we suggest to use a valid certificate especially for the load balancer. After installation, you can find a folder, a specific folder in the SM.I.LE80 solution, in the specific resources cert root CA, and this is necessary important to install this certificate in your browser to have a secure connection, because especially when we use a custom certificate authority to configure the system. For example, for Chrome, it's possible to find the CRT file in the folder, open certificate manager in the browser, in the specific in the Chrome, and then import it in the authorities tab. After this, this is possible to access to the system in a secure mode, as you can see in the figure. This is important because if you don't have the secure connection and is not trusted connection, is not possible to use correctly the web UI, and it's not possible to access to the system. So how the certificate are managed? So we have a configuration automatically related to the certificate, with a creation automatically of the certificate. In fact, the certificate are creating using a custom certificate authority if it's necessary, with the duration of 30 years. And during installation, as you saw before, the certificate are distributed on all machine properly, and the certificate bound to properly endpoint and application. Important things to consider: that Nginx certificate, it's necessary, it's important to have a valid certificate, so validate from a valid certificate authority. It's not possible. The system, the installation process, give possibility to generate a custom certificate, but it's necessary to have a specific procedure on the customer plant to configure a secure mode, to have possibility to connect to the system via web UI. Okay, I completed this module.
Thank you, Giuseppe. Any questions? If there are no questions, the module ends here.
Okay. Thank you all.
Thank you all.
Thank you. Bye.
Thank you. Bye.
Grazie.
Bye.
Bye.
See you tomorrow. Bye.
Thank you.
Bye.
Bye.
Thank you. Bye.
Bye.